All right, mathletes, so let's look at some exponent rules, and we got some practice for you too, all right? Because you can't just look at these and say, all right, I got it. You got to make sure you practice them to really check to see if you do understand what we just learned here. All right, so exponent rules. The first exponent rule we're going to look at is the product rule. The product rule, all right? And check it out. The product rule says when these have the same bases. So when you multiply, so to multiply, when two bases are the same, right, all we're gonna do is add their exponents. It's that easy, all right? So let's do an example here. So let's do an example. So let's say we have x to the 5th power times x to the 8th power. Now remember that little dot there means multiplication, all right? So just like this rule says, we add the exponents. So we have 5 plus 8. So you're just left with 13 there. All right. Let's do another one. What if we have numbers, right? So again, the rules do not change because the variables, they just represent numbers. So let's say we have 2 to the negative 3rd power times 2 to the 8th power. Once again, the bases are the same because as we always say, it's all about that base, So we add the exponents. So negative 3 plus 8 is 5. So you're left with 2 to the 5th power. And we could go ahead and write equals 32. And I'm just going to leave it as 2 to the 5th power because right now we're just working on the exponents. But when you do have a number raised to the exponent, go ahead and simplify. Okay. But again, I'm just teaching you about these exponent rules right now. All right. Things might get a little bit more complicated down the road there, right? So what if we have, let's say, x squared y times x cubed y squared, right? So what you can do, and what I like to do as I'm teaching this, is I like to tell my Dr. Mathletes across the world to first reorganize things. This is multiplication. So remember, when you're multiplying, we're allowed to rearrange the order, right? We got that commutative property there. So I'm gonna rewrite everything. So I'm gonna get all my x's together. In real life, that's probably not a good idea, but in math, it's a great idea. And then I'm gonna get all my y's together, all right? So it's easier to see now, oh, I could apply this product rule and now I could just add the exponents for those bases that are the same. So here I end up with x to the 5th power because I'm adding 2 and 3, right? And then don't forget, whenever you have a y, there's really an invisible 1 for its exponent. So write that down just in case you think you might forget that. So you're left with y cubed because again, there's an invisible 1 right here. Boom. Just like some of our invisible friends. Right, Pat? All right, making sense? Good, follow me to the next examples. All right, next we have the quotient rule. All right, and quotient, remember, means when we divide. So just like multiplication meant we add the exponents when they have the same base, the quotient rule says that we're going to subtract the exponents, and it's always the top minus the bottom, right? That numerator, the exponent of the numerator, minus that exponent of the denominator, just like you see right here. So top minus the bottom. So let's do some examples here. And again, some people make the mistake of they'll always do the bigger one minus the smaller one. No, top minus the bottom, right? So let's say we have x to the 5th over x squared. So here, all we do is we write one base, that's key, and then we have the 5 minus the 2, or just x cubed. So again, all we do is subtract. Same thing happens if we have numbers, right? So say we have 3 to the 8th divided by 3 squared. So once again, we subtract the exponents. So we have 3 to the 6th power because we did 8 minus 2. All right. What happens when things get a little bit more complicated? So let's mix these together. So let's say we have, I don't know, x to the 5th, y to the 8th, and then y squared, x cubed. All right. So again, when I first start with the x's, right, I could only work with these two because they have the same base. So I'm going to have an x here, and I subtract those exponents. So the exponent associated with the x's is 5 and then the 3. So I'm going to subtract those. So 5 minus 3 is 2. And the y's, again, it doesn't matter where they're located, because in multiplication, because these are being multiplied, we can move things around. So if you wanted to, you could change the order. But here, it's just to identify these have the same bases. So because they have the same base, boom, I subtract the exponents. So I end up with y to the 6th power, right? That easy. Any questions? Good, follow me to the next example. All right, so now for the 0 exponent rule, and people mess this one all the time. And I know why, because they haven't subscribed to Dr. Math and haven't smashed that like button. So make sure you do that so that plenty of people out there get to watch these videos just as you're doing now, right? So we need to get the word out. We need people to get these videos in their hands so that they can get the help they need. All right, Matthew, so I appreciate that. All right, so don't forget to do that. So check it out. Anything raised to the power of 0 is 1, all right? And so, except 0, of course. So what we're gonna do, let's say we have y raised to the power of 0. Well, that's just 1. What if we have 600 to the power of 0? Well, that's just 1. And one thing that people mess up all the time, and I'm gonna reiterate this at the end of the video, that's so important, is say we have something like this, and then raise it to the power of 0. Right now, this exponent only belongs to the z, right? But if everything's in parentheses, right, now this exponent of 0 belongs to everything. So this, right, is what I'm raising to the power of 0. And we just said anything raised to the power of 0 is 1. So again, even though this might be as complicated and look pretty crazy, once you raise everything to the power of 0, boom, our rule says it's just 1. It's that easy, folks. Follow me to the next example. Well, what happens when you raise a power to a power? Good question. So when you raise a power to a power, all you do is multiply the exponents, right? So it's like my high school teacher would say, raise a power to a power, multiply the exponents. So let's do an example here. Let's say 2 to the 3rd power and raise that to the 5th power. So whenever you have a parentheses like this is just telling us, according to our rules, is to multiply that 3 and the 5. And again, all these exponent rules, you're gonna see them play out over and over and over again in math. So make sure you really understand them, because they're really gonna help you save a bunch of time. And if you know how to manipulate things, you're gonna be very creative and save yourself so much time down the road, right? So again, very important rules to understand here. What happens if we have, I don't know, z cubed, that's a 3, and we're gonna square that. So 3 times 2, boom. So we have z to the 6th power. All right, so again, these rules aren't very difficult. What people start to do is, as this evolves and it becomes longer, they kind of freak out and they forget all these rules, right? So again, make sure you really know how to apply these rules. So there's our power rule. So let's get some more rules. So now we have an expanded power rule. So let's do some examples here. And what you're gonna see is what happens when we have, I don't know, multiple factors in our parentheses here. All right, so according to our expanded power rule here, what we're really gonna do is distribute this exponent to all of the exponents on the inside for each base. So what I like to do is, I'll tell my mathletes all over the world, is first make sure you know what the exponents are. So in this case, because you couldn't visibly see that each exponent was 1, I wrote it so that now I know, oh, this 3 is just gonna be distributed to each one of those exponents. That's what the rule tells me, right? Gotta do what the rule says. So you're left with 2 cubed times x cubed times y cubed. So it's that easy, right? So again, it's just like our power rule, but now we have more than one base on the inside. All right, well, same thing that happens if, get another example here. Same thing happens is if we have a division. So say we have 3x divided by y and raise that, I don't know, to, we'll say we'll square it. All right, So again, what I like doing is I like putting exponents there if they don't have any. Well, we know they have an exponent of 1 if there's nothing there. So visually, right, visually I could see I'm going to multiply the 2 by each one of those exponents. And the big mistake, beware, and I'm going to talk about what to be careful with, is don't multiply 2 times 3. So again, do not multiply. So this ends up being 3 squared. So you multiply it times the exponent. Do not multiply it times the base. That never happens. And you get x squared and then y squared. It's that easy. And of course, we know this would be 9. But again, I'm just showing you how to use these rules. And I know what you're thinking, but Dr. Math, what happens when we have negative exponents? Right? Don't worry, just follow these rules, right? These rules and these properties, once you understand them, right, it's not hard. So when we have a negative exponent, what's going to happen is that base is going to go to, if it's in the numerator, it's going to go to the denominator. If it's in the denominator, it's going to move up to the numerator. So essentially, we're taking the reciprocal of that base. So let's take a look here. So let's do an example of our first example here, x raised to the negative 7th power. Well, that's just the same thing as 1 over x, and now that negative 7 turns positive. Turn that frown upside down, all right? Boom, it's that easy and we're done. Likewise, if we would have had, say, 1 over a raised to the negative 5th power, well, notice that base of a is on the bottom. So notice Dr. Math started at the bottom, but now I'm here. So we're left with a to the 5th power. So that negative exponent, boom, just shot up to the front, to the top. Right? So again, these rules are very helpful because they're going to make life easier once we really understand how to manipulate these things. Let's do another example. Let's say we have 2x cubed over y squared, and we're going to raise that to the negative 2nd power. All right, so a few things are happening here. Actually, before we go beast mode, before I do the negative 2nd power, let's just do what happens when it's raised to the negative 1st power. So all that happens with that negative 1 is it flips it. We're going to take the reciprocal. So this turns into y squared all over 2x cubed. And people are wondering, but what happens if it were, right, 2? Then you would have just multiplied each one of these exponents by 2. And we'll do an example like that at the end. Don't go anywhere. All right, so those were our rules. We'll look at a few examples combining everything, but here are some warnings, things that I do not want you to do that I see all the time. So people are making up math all the time. So don't do that. Right, so check it out. Negative x does not equal 1 over x, right? When our exponent, right, when our exponent is negative, that's when things start to move around, right? Not when the base is negative. So this is not true. So negative 3 does not equal 1/3. I cannot tell you how many times we've seen that. And notice when you have an exponent, this exponent belongs to the base. So here the base is negative 3 because it's in parentheses. So what this means is negative 3 times negative 3. That's very different than if I didn't have parentheses, because now, because there's no parentheses here, then this 2 only belongs to that 3. So that negative just comes along for the ride, right? So please make sure that you're aware of this because it will mess you up. All right, so let's kind of bring some things together. Let's get some last practice examples. Let's go beast mode here. What happens if we have negative 2x squared y to the negative 4th power, and say we have negative 2. All right, so according to our properties, if we look back, we know that this negative exponent is going to shoot everything to the denominator. This is one way of doing things. Some of you might prefer to distribute that negative 2 to each one of these exponents first, and that's perfectly fine as well. So this is what I love about the rules, is you don't have to do one first and the other, right? Whatever one makes sense first to you, you could go down that route. So here, this is the same thing as 1 over negative 2 x squared y to the negative 4th power, and now that 2 becomes positive. All right, so all I did is I took into consideration that negative exponent, which meant boom, all this base here moved to the bottom, and now my negative 2 becomes positive. All right, so now what happens when I have this 2 on the outside? Well, now I got to distribute that exponent, right? So let's go ahead and do that. So we're left with 1 over that negative 2 is going to have an exponent of 2. That x squared is going to have an exponent of 2. That negative 4, right, that y to the negative 4th is going to have an exponent of 2. So here, I'm just really taking it step by step. Some of you will just multiply it and be done with it. But here, I just want to take it step by step here so we could see what we actually did. All right, and now you're left with 1 over negative 2 squared. Notice typically I would just put a 4 right there, but again, I'm just teaching you the exponent rules. X to the 4th and then y to the negative 8th power. And here's something we don't have in mathematics. You never want a negative exponent, right, for your final answer. Plus, you would simplify this as well. We never want a negative exponent. So what's going to happen is we're going to need to move this negative 8, y to the negative 8, boom, to the top. So upstairs, we're going to have y to the positive, right, 8, y raised to the 8th. And let's go ahead and just write 4x to the 4th, because negative 2 times negative 2 gives us that 4. And there you have it. You have no more negative exponents. So again, as you're getting comfortable with this, right, use one rule at a time, one of these properties at a time. And again, it's not so bad. But what people try to do is they try to combine properties and do it a little bit too much, right? So make sure you review these properties, you write them down, and make sure you understand. All right, so here is your problem of the day. All right, athletes, so now it's your turn. Problems 1, 2, and 3, go ahead and comment down below your answers. And when you're typing your answers in the comment, for the exponent, use the caret symbol. So this is our exponent sign. So let's say your answer is 3x to the 4th. The way you would write that in the comment is 3x caret and then 4. And that's how we'll know what your answer is. All right, so comment down below and don't forget to like, subscribe, and we'll see you mathletes in the next video. Peace.